Let's go.
Thanks everyone for coming. We're super lucky to have Andrew Fleury here, who is the founder and CEO of Luna. And Luna is doing really great work around bringing really precise positioning and computer vision to micromobility vehicles. And this is allowing operators to get a really granular, real-time understanding of where their fleet is at all times and how to manage it in the wild. So Andrew's going to talk us through some AI tools that they're using, such as parking selfies, to ensure that riders are behaving well and that they're complying with parking for micromobility vehicles. So please welcome Andrew, and I'll join at the end just to wrap things up. But thanks for coming, Andrew.
Great, thanks a lot, Alessandro. Delighted to be here, and I really appreciate the opportunity to introduce the company and the work we're doing. Just really think that the work that you guys are doing has been fantastic for the industry. So yeah, let me get into it. So as Alessandro said, we kind of concentrate on computer vision for micromobility, and really, obviously, we're quite bullish on it, but we do think computer vision can be really a game changer for the whole industry. Our view is that micromobility's had a very rapid growth, and continues to grow rapidly, but we kind of hear a couple of barriers coming back all the time from the cities, and we think if we could help to minimize or to remove those barriers, then micromobility could go on further. And really, I think everybody probably at this conference is on the same kind of mission, is to reduce or remove cars from an urban environment. So that's really what we're about as well. The kind of key areas that we work is making sure that a scooter or an e-bike is on the correct surface. So we recognize roads, sidewalks, bike lanes, and other types of surfaces. That's one of our core pieces of technology. We also look at the environment around the scooter, so if it's in a crowded area, if there's pedestrians. And then thirdly, we look at proper parking, which is going to be the main focus of the presentation this evening. So yeah, let me just kind of move on. When we are working in this space, we're really trying to kind of cover all stakeholders. So really, our customer is the scooter operator. We've been lucky to get kind of pilot deals with Tier, with Voi, and we've got a couple of others that we'll kind of announce in the coming weeks. And that's really our core customer, but then we're really conscious of the relationship that they've got with the city and with the rider. And on each side, within the city, they're trying to offer more transport and mobility options. And then with the rider, we're kind of conscious that we have to get the experience right. So for example, if we had sidewalk detection and that feature wasn't attractive to a user, and they used a different scooter or a different form of mobility, then that's not good either. So that's really kind of core to what we do, is to try and work not only on the technology, but also the user experience. Just going to show you kind of a quick video of our sidewalk riding. I'll just press play here, and hopefully you guys can see it. I picked this video because it's not maybe the most pretty video we have with the kind of clean lines, but what we're looking at here is a segmentation and detecting the bike lane, sidewalk, road. I picked this one out because I'm just really proud of how it's all come together. We've got some really tricky conditions here. You can see the kind of sunshine. This is wet roads, and yeah, it's just for me, this video was kind of a milestone to show how far we've come along. Like when we first started working on this technology and on these algorithms, this set of conditions would have been our worst nightmare. Rain, sun, all of those things. And where we are now is that we've got a really robust technology that's going to work in really any conditions. I'll just jump ahead to look at some of the work we're doing in pedestrian detection and object detection. And this is the idea that we want a scooter or a bike to be conscious of the kind of surrounding environment, and then collaborate with the operators to say, okay, what do you want to do next? So the algorithms are really good at picking out the different objects, working out if they're moving and things like that. And an example use case might be a go slow zone. So now almost all operators would have go slow zones. They might put one outside a school or a park or something like that. But that go slow zone is quite limited because all it knows is a set of rules, like maybe it's a go slow zone at certain times or on certain days. Whereas computer vision allows that to be kind of intelligent, so it can know if it's a busy area and it's not appropriate for a scooter to do 15 or 20 kilometers per hour. That type of environment sensing is going to be really a game changer for shared micromobility. And I think it's something that we're starting to see come into also the owned space. We're starting to get queries from e-bike and scooter manufacturers that are offering an owned solution, albeit our initial offering has been towards shared. We're starting to see the owned market looking at this type of technology too. So that's kind of one area of our technology. We see ourselves as a really innovative company. Some of the innovations we're looking at is all around the smart city space. What can we do using these cameras as sensors as they go around the city? And we've done a lot of work on that. But one of the innovations that's popped up quite recently is the idea of making a smart parking selfie. So many operators have used or are using a parking selfie, and it's a tool that's used to kind of help parking compliance. But really the image itself, there's too many for anybody to actually manually look at, so it's of limited value. So we broke out one of our algorithms and decided to put it up as an API. I'll just play this video and you guys can see an example. So what we're looking at here is a screen recording from our demo app. So my colleague Chinmaya, he's going to park the scooter in a bay. This is from Zip Mobility. They're a Dublin-based scooter company. So we see the snap. Right now it's as an API, so it's going back to the cloud. It's pretty fast. We worked hard to make it as fast as we could. And then you can see what's happening in the image is we are recognizing all the kind of key attributes of the parking event. So we look at the scooter, we recognize the wheels, we recognize the logos on the ground, we recognize the painted corners. We use all of those to then basically determine whether the scooters park correctly. And because we're recognizing all those different features, we can essentially make a parking score and create a type of logic to say, well, what do you want to do, or how strict do you want the parking logic to be? But yeah, so the other key element is to train the bay. So what we've got to do is train certain elements of it. Logos, things like that need to be trained. The way we've built the technology, we can do that very quickly. We do that by taking in some video of some bays and then training that out. So if anybody's interested to try this out and they have their own specific bay, we'd love to talk to you and show you how quickly we can get you up and running. Yeah, so we're very conscious that parking it's not checkers, it's chess, right? A lot of things happen. It's very much in the wild, and we're conscious that this is a tool and that it's something that needs to be built on to really go towards fixing the problem. But some of the things that we're working on and experimenting on is the concept of bay history. So I'm going to show you a few images taken from around Paris just last week. And it's the idea of bay history is how did that scooter get there? Why did somebody park it there? There's a couple of reasons that we can kind of wonder about. Like maybe at one point in time that bay was completely full and there wasn't room. Maybe somebody was trying to get another vehicle out of that bay and they moved it onto the curb, but how did that get there? And the idea that the AI algorithms could look at a series of images taken over the course of a day or a couple of days and work out what went wrong, maybe that would bring data towards how we could improve parking going forward. We can easily recognize knocked over bikes and scooters. That's obviously a problem. In this case, you can see it's taken up a huge amount of capacity for that bay. So recognize these knocked over vehicles, and then what happens next is important, right? The data is there. So how do we fix that? We could recognize crowded bays very easily. So we're currently counting scooters. Is there any room in the bay? In this case, we see there's maybe one more slot, but then again, using that data maybe to help a user to plan their journey, maybe don't come to an overly crowded bay. Also that data is going to be fantastic for the city, right? To know where are bays constantly overflowing. And the fact that we're using these images and we can count scooters is really nice because it works across operator, right? We can count a Lime or a Tier or a Voi or a Dot just as easily. So it's almost operator agnostic in that sense. And then finally, one of the other things we're looking at is almost a health score on the bay. In this example, you can see what's happened is somebody's done some road works on the bay and the paint has gone bad. We would still recognize this in this instance because we've got a really nice clear symbol. And we've got 3 scooters, so we'd use both of those factors to recognize the parking bay. But yeah, you can see that the normal line and paints wasn't as clear as the other ones we saw earlier. So there's another piece of data and could feed into the smart city kind of ecosystem, and maybe the city could come and fix that. So yeah, kind of what's next is sort of a call to action. We're very, very conscious that we've got a piece of technology. It's a tool. We're evolving it, but this is something that needs to be worked into the fabric of the user experience and the app. So yeah, really excited to work with partners, with operators. If anybody's interested to test out the API, we'd be delighted to talk to you guys. I think we've got a couple of minutes left. So any questions, anything like that, happy to take them.
Yeah, I guess maybe one question I would have is what are maybe the specific edge case challenges that you've had to account for in a lot of these AI-based computer vision tools with respect to maybe the parking bays or lanes, or just what's been one kind of big challenge that you've had to overcome in building out this software?
Yeah, well, I think in maybe I'll give you one from sidewalk detection or those kind of things. Every city has what we would call kind of weird parts, and what you're going to see is, I could take you, Alessandro, drop you on a street in the middle of Dublin or London and say, are you able to? Is this road pedestrianized? Are you able to cycle? Are you able to drive? And you can't really tell at first instance. So that's definitely a challenge. Thankfully, there's not that many of those roads. And then also, most of the operators have got geofence solutions for those kind of things. So we see a sort of a fusion. You can either train out those instances. You can fuse it up with the geofencing technology that they're already using. So really, that's an example of a challenge, but yeah, maybe going into parking, the other challenge you see is that the paint is often imperfect. So you've got to factor in other characteristics, look for logos, look for a number of scooters together, those types of things to try and give you a confidence score rather than a binary answer of yes or no.
Yeah. So there are kind of like city specific these softwares to recognize different infrastructure that's not like harmonized across cities.
Yeah, exactly. And kind of the operators we've been talking to, a lot of people ask us, what about free floating? Can this technology be applied to free floating? So we're certainly looking at that. But what what computer vision algorithms like is, really clear set of rules that they can work against. So is there paint on the ground? Is there a number of scooters together? That's much easier. If it's free floating and you're looking for things, there's a lot of variables, right? So you could say, for instance, okay, well, I want it to be really close to a curb, but there's just a lot of variables around that. So the more kind of logic you can apply to it, the easier it is to put the algorithm in place. Got a question coming in there. Do you need IoT for lane detection? So yes, we put a camera onto the vehicle. So it right now it's a fully connected camera. It's got its own modem. We've got a new version coming in the course of this year, which will integrate with IoT. So it removes the modem and it's kind of more integrated. But the version we've got now has its own modem and works that way.
Great. Yeah. Thank you, Saad, for that question. And yeah, Luna is really they're the leaders in this space, and we're really lucky to have you here, Andrew, joining us from Dublin. And thanks for sharing all of this really incredible work you're doing. Really, again, thanks Andrew for joining us, and yeah, thanks everyone.
Thanks, Alessandro. Delighted to be here.